From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 330, recorded live Thursday, July 26th, 2012. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Microsoft Azure Product Team member and author Mark Russinovich.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm sitting in Building 109 on the Redmond campus of Microsoft with the one and only Mark Russinovich. How are you, sir?
Hey, Scott. Doing well?
I'm doing pretty good because I just finished your book.
Yeah, I saw you tweet about it.
Yeah, actually, I tweeted directly from my Kindle. I've gotten in the habit of finishing books on my Kindle and then tweeting directly from the Kindle and doing it. And the best part about it was that after I finished, the Amazon Kindle said, the next book is coming out.
Oh, it told you that?
Yeah. So it's like there's 2 in the series. Someone has added that metadata.
Oh, that's pretty cool. I didn't realize that it did that. I read books off Kindle too, in the Kindle app, but
so somehow they're pulling that from some metadata Wikipedia now that it knows that there's the second one in the series. So the book was called 0 Day, and I don't know why, but I think I thought when I started it that it would be focused at like me, the nerd, but it really bridges 2 worlds. I mean, you can read it and go, wow, that's technically correct. And wow, that's technically correct. But at the same time, it is a mainstream novel. I mean, you want regular people to read this too, right?
Yep. I definitely, when I set out to write the book, I wanted to appeal to technical people, and I wanted somebody like you to sit down and read it and not go, cringe and cover your eyes and go, that's just ridiculous, or hop from point A to point B with magic in the middle, which I can't stand in books. Mm-hmm. I like, if everything in the book, I hope you notice this, but I try to make it clear how things got from point A to point B. I don't, at least so that you can figure out how things got from point A to point B, and not that magic happened, unexplained circumstances got us the plot moving forward kind of thing. But I also wanted to appeal to the mainstream audience too, to educate them about what is computer security and what's this world that really everybody's living in, whether they realize it or not.
Would you say that the essence of the book was to scare or to educate, or a little of both?
It was a little of both, actually. I think that this threat that I portray in the book is absolutely one that I consider very realistic, and I'm surprised that it hasn't been taken up up to this point. I figured that we would have already passed the book in reality some time ago, and I was concerned, actually, it took so long to get the book published that it would be obsolete by the time it came out. It'd be viewed as historical fiction. So in that sense, I was lucky. But I do think that it's just a matter of time before somebody that just nefariously or maliciously, just mischievously goes out to cause destruction just because they can through this means of using cyber weapons, malware, to do so.
Everyone thought that everything was going to fall apart in Y2K.
Yeah.
And it didn't. Not because the problem wasn't pervasive, because it was, and not because lots of things didn't break, because they did, but we did fall back onto existing things, and nothing major broke. I mean, I don't think any dams fell over because of Y2K.
Yeah.
Was it because of the media overblew it, or was it because maybe computers aren't as pervasive as we think, and they aren't as important as we think that they are?
Well, I think in Y2K, if you think computers were pervasively used around the year 2000, it's orders of magnitude more pervasive now. Just literally last week, Obama published an editorial in the Wall Street Journal, which starts out, I was just called in my top security advisors. The water supply in major cities had been polluted. The trains had been derailed. And there was a simulation. It was a simulation of a cyber attack on our critical infrastructure. And the reason that he did that editorial was to help promote legislation that's trying to get its way through Congress to require companies in the private sector that are responsible for our critical infrastructure, like water and gas and electricity, to have to adhere to certain cybersecurity guidelines that they don't have to today. Basically, everybody's on their own to do whatever they want to, which leaves us incredibly vulnerable to this kind of stuff.
You know how when you're out in the world, you see blue screens, but not recent ones. NT4 running Alaska Airlines' kiosks, or as you travel, you spot these things. it seems like a lot of our security and a lot of our infrastructure is running on incredibly old operating systems.
Yeah. And that's even more so for the SCADA type systems. The SCADA, the supervisory control and data acquisition systems that are used to run like power plants and generators and even centrifuges like the ones used in the Iranian nuclear program. Those are both old, and even the new ones, they're just not designed for an environment where they're exposed to hostile threats. They're really designed for, hey, you're putting this thing into a controlled environment where only trusted people and code is accessing it, and so we don't need to be really rigorous about security. And the fact is that that's no longer the case. This stuff is all basically exposed to the internet, either directly or indirectly, as we saw in the Iranian Stuxnet attack, through USB keys that walked into the facility, and then those SCADA systems are basically indirectly exposed to CIA operatives sitting in Virginia. And the fact is that these systems being used in this way, they're not designed for, is part of that weakness that we've got now at this point.
But is the problem a technological one or a social one? Because you use the example of USB keys, and I always thought it was funny that the real attack would come when someone flew over and dropped USB keys in like any major corporation's parking lot.
Yeah.
You just pick them up, free DVDs or whatever, you put it in and boom, you're in. I mean, that's, USB keys are a social problem.
They are a social problem. And actually, doing a mass attack with USB keys, I think people would start to figure that out. But you drop a few in a parking lot, and actually anybody that's in the penetration testing business knows best way into the front door of a business is just dropping a USB key in the parking lot.
Yeah.
Or a few, right? And then they're going to show up on the internal network there, and somebody's going to click on whatever's on it to see what's going on. And they're inside the network at that point.
So that's a social problem, though. But I mean, we can train people not to do that.
Yeah.
That's an easy thing. Get the word out. We can change the operating systems to do different things around autoplay, and I know that Windows has done that. And then the culture of automatically doing something upon user action is changing. But what do we have to do to the operating systems to make these things more secure? I mean, these SCADA systems were designed 10, 15, 20 years ago or longer. In a world where there was a kinder, gentler internet or no internet at all. They're never going to upgrade. The people who wrote those are retired. Yeah.
Well, I think we face a hard problem there. We've got to upgrade them or we're going to be left to insecurity, because part of it, like you said, is social aspect of it. But even if you train people, the software still has vulnerabilities that can be exploited. So I work my way into your network through some software vulnerability. Now I'm in your network, and then I get into the SCADA system, which has its own vulnerabilities. So what we need is multiple layers of defense. You need best security practices at each layer in the system, certainly as you get more towards the hardcore center. You need, of course, the training that goes with that for people to be secure. But where you can, I think technological solutions where people don't have to remember to be secure are the best ones. And you see this trend towards creating these kind of technological solutions to make our systems more secure in the mobile space. If you look at what Apple's done with the App Store, basically that's whitelisting, curated whitelist. So the operating system won't run anything that's not been approved. And Apple's got this very rigorous process of approving the software that goes in the App Store. And Microsoft's going to have the same thing for our App Store for Windows 8. But we've seen how incredibly successful that is. When you compare the kind of infections that you've seen on iOS devices with what you see on Macs even, or Windows devices, there's been almost no activity there. And the activity that's been there has been very controlled, because once it's identified, it's slapped down pretty fast through the hands that reach down from the cloud and fix things. So that's an example of technology that's really helping address part of this problem that social engineering ends up causing. Now, it's not going to be perfect, and there's going to be cases where the software running on these devices is vulnerable. The browser has a vulnerability and you navigate to the wrong place and you're going to get something there. But then technology can also take over there with sandboxes that are running in the OS to try to contain the infection.
So when I try to explain stuff like this to my wife or my mom or the non-technical people in my life, from their perspective, they take an action and something happens and it's their fault.
Yeah.
So, whether they click on Word and they run Word, or they click on evil.exe and something bad happens, there's this kind of half guilt. I clicked it was my fault. And then there's well, why didn't they protect me?
Yeah.
We have things like Smart Screen and different, antivirus definition type stuff. I kind of get that in the user space, but then in the book, what's used to attack us is what's called a rootkit.
Yeah.
What is that?
Well, a rootkit is actually it comes with the malware. So the malware has to get on your system, and then once the malware is on the system, it can use rootkit techniques and technologies to remain on your system. And really, what does it take to remain on your system? Part of it is I'm hidden, so you look for me, and you're not going to see the malware. And the other part is, of course, even if you do see part of me, it's impossible for you to remove me once I'm there. Yeah, so the rootkit is really a cloak, basically, that the malware puts on once it's gotten into a system. Stuxnet had an example of this when to conceal the fact that it was being transmitted by USB keys, you'd stick in the USB key. It would exploit a vulnerability in the operating system to jump into the OS. And this is independent of autoplay. So it was exploiting a vulnerability in Explorer. So no action by the user. Autoplay restrictions didn't prevent this thing from jumping onto computers. And then once it was in Explorer, it would install a rootkit filter in Explorer so that you would look at the USB key and you wouldn't see the Stuxnet files there. So the instant you stuck the key in, the files would effectively disappear. So you wouldn't even know that you'd gotten this payload along with the USB key once your machine was infected. So that's an example of a rootkit there that Stuxnet was using.
So is rootkit, that term, is that a family of techniques?
Yeah, it's a whole family of techniques. Basically, I kind of summarize it as techniques that the malware adopts to hide its presence from standard administrative, diagnostic, and security software.
Now, as a technical person, and I know I've read these kind of CSI essays on your blog, I think we've all had that experience where we've opened up Task Manager and we've said, what is that?
Yeah.
You just have that open. I know that in early versions of Windows, I had Task Manager open pretty much all the time, just sitting on another window because I want to know what's going on. I wanted that insight. And as soon as I spot something on a family member's machine, I'll immediately figure out what's going on. And you do these kind of CSI things where you dig in and you say, oh, look, it's ActiveX control, and now it's loading itself in the registry. And then you delete. You run, crap cleaner, and everything is okay. Are you saying in a rootkit I can right-click on Task Manager and it's there, but it's not showing up when some operating system level call says enumerate processes?
That's right. That's exactly what's going on. So that's an example of not hiding files, but hiding processes. And this one's really common as well for rootkits. So there's lots of different ways they can do this, from manipulating the kernel data structures, the list of processes. So user mode application like Task Manager calls into the kernel and says, get me the list of processes. Well, the process list data structures have been manipulated so that the malicious process is not even on that list. So it's returned from the kernel without the malicious process. Or it can be done up in user mode. So the kernel routine returns the full list, including the malicious software, but the infected process, something running inside a Task Manager, then takes the malicious process out of that list. That it then is handed back to Task Manager for it to display. So, and then there's lots and lots of variants on that same kind of technique of hiding something from a tool like Task Manager.
I've taken, operating system classes in college, and I did Minix and all the little tiny OS classes and things like that. Is this unique to Windows, or is this operating system theory kind of stuff?
Yeah, this is operating system theory. So yeah, it's not like Windows is especially vulnerable to this kind of stuff. Macs, you can do this, and Linux, you can do this, and Minix, you could do this. Same kind of thing.
But how do you, you guys are all here, we're here in building, 109, and you guys are kind of designing the next version of Windows. Do you have to double check everything in the sense of at every moment the system is running and it has to, test its assumptions?
Yeah.
Does Windows itself have to say, this is what I know Git processes looked like when we shipped, and every minute I'm checking to make sure it hasn't changed?
No, we're not really doing that kind of thing. So I'm working in the Windows Azure team, which is developing a cloud operating system. You could say we're delivering software into the data center. And
Sure.
The question is what did we deliver it here? Actually, what's running in the data center? And this is a place where we've got standard images. So we actually deploy images flat onto machines.
Right.
When we update them, instead of taking an approach where we go and just send updated bits to the machines. And what this does is make sure that when we believe that something's running on a machine, that it is actually that set of code that's running on the machine, at least when it's deployed. And we can understand the state of a machine as it goes along. We haven't implemented whitelisting in the operating system in Azure for guests or the hosts, but we're working on implementing that as well as an extra lockdown of the systems that we've got in place. So the question that anybody has of is what's running on my machine really what I think is supposed to be running on a machine, or something not something there that shouldn't be there, is one that everybody has to deal with, and one that there's no silver bullet for. So I'll say, even in the face of having perfect antivirus, having perfect whitelisting, take the iOS device example that I gave you earlier. If you go to the App Store and there's a vulnerability, or if you go to the web using the browser in iOS and there's a vulnerability in the browser, malware gets down on the iOS device and it runs in memory. So it's not violating the whitelist, but it's something that's active on the device at that point. Then you're infected. And really the only way to clean it off is then to reboot the device, or to get antivirus down there to go and clean it off, delete the thing. So it's not like there's a magical solution that means no malware is ever going to be on anything, no matter what. It's a matter of trying to make it harder and harder and harder for malware to do that, to get on a machine. And then once it's on the machine, I think this is a key part of cybersecurity, as we'll see evolving, is mining data to look for malicious activity. Something that really, there's been some work, but I think there's a long way to go here. And this is, you're going to see this become more popular as big data techniques come into play, where you can analyze systems and look for anomalous patterns of network traffic and use statistical algorithms to go and help you pull that stuff out and say, wait, there's funny traffic going on from this machine to this machine over here that then ends up going to this machine that then ends up going off into, some server in Hong Kong.
Right.
So I believe that this machine here at the core of it is infected, and you've got a pipeline out of your network. You're going to start to see stuff like that by analyzing network traffic and log files. And
yeah, well, I used to work in online banking, and when we were shoving SOAP around, they started putting stateful firewalls in between machines to look for things leaving. You don't want any other traffic than what is expected.
Yeah.
Complete whitelisted, traffic.
Yeah. So just another tool in the bag of tools. But
now, you brought up something interesting, because you work here in Azure, kind of not necessarily downstream from Windows Server, but you're kind of a client of Windows Server, and you've got this cloud-based operating system, which is an operating system of operating systems.
Yeah.
And you said that when you want to make sure that a machine is in a good state, you could do all sorts of heuristics like I kind of made up right there, but that really isn't efficient. Better to just torch that machine and lay down good bits again.
Yeah.
And that was interesting to me, because in the book, a great deal of time was spent when one company was attacked looking for a backup. They spent a great deal of time going farther and farther back in time to make sure that they had a good image, because they were concerned that they'd actually backed up the virus.
Yeah.
But I thought that was interesting, because they were looking to kind of TiVo their computer. They just it was good Tuesday. Can't we just go back to that last known good state?
Yeah.
And it would be nice to be able to do that. And I think we've got that.
Yeah,
now.
Windows 8's got that. Yeah.
Reset
it to the factory settings. And actually most mobile devices have that as well, right? Reset it to the factory settings.
Yeah, I've done that several times with my iPhone. Just torched it and went back to the way it was.
Yeah.
Interesting. One of the things that also struck me in the book was that there was a lot of thought and talking. You didn't kind of cover up anything with action.
Yeah.
It was a lot of prose. And I kept wondering, was something going to break out into an action thing? It's no, this is two people sitting down and actually analyzing it. So it was almost like we were there over the shoulder of the protagonists as they were having this conversation. So I compliment you in the sense that you didn't dumb it down.
Yeah, I felt like if you can make a cyber thriller that's really thriller with no cyber, and I think there's lots of people that do that.
Yeah,
yeah. The people that are more focused on just thriller genre that will toss cyber terms in there, but it's really just a week, just sprinkling cyber across their book. But I really wanted to make it really about cybersecurity.
Mm-hmm. And the backgrounds of the people, how they got into security, and the kinds of analysis that they use. And some the protagonist came in, kind of through a more governmental way to learn what he learned, while the female protagonist came in a different direction. Were those based on people that you knew or came upon? Are these realistic portrayals of how people get into security?
I think they're realistic portrayals. The only character that I think is more based on a real person is the main protagonist, Jeff Aiken, who's kind of based on me. So actually,
right. Well,
yeah, right, exactly. And I think I saw that this is a common pattern with first-time authors, is they're kind of autobiographical. Their first novels, they're themselves projected into the book in some manner, and Jeff Aiken's kind of a projection of me into the book.
When you were writing it, you had made the comment a minute ago that you didn't want to jump over anything. There was a linear structure to it and a focus that felt like a programmer.
Yeah.
Did you have anyone who worked with you on it to make sure that the narrative flow was the same, or did you write this like code? I'm interested in the process.
Did I write it like code?
You sit back and you
yeah,
whiteboard it.
I did whiteboard. I did plan the plot ahead of time. With less detail towards the end than the beginning, but I did have a structure like, okay, then this is going to happen roughly, and then this next step is going to happen, this next step is going to happen, and how do I make these things all line up? So kind of like building, a framework there where I wanted all these different pieces and lines to come together in a way that would be interesting. The challenging thing about it is Trojan Horse, the sequel, got more complex, so it became a harder problem for me to solve, to have all the plot lines come together in an interesting way where I didn't have to hand wave through things, and where I didn't recover turf that I'd already covered in 0 Day. So I'm actually working on the plot for the third book in the Jeff Aiken series. And that one's even more challenging because it's like, oh, I can't use that device because I use that in Trojan Horse. I can't use that because I used it in 0 Day. I don't want people to go reading through the book and go, oh yeah, I remember that from book 2, but really it to be fresh. So it's kind of fun because they're brain teasers that are getting harder as I go along.
Do you think that would be challenging, though? Because I think from a layman's perspective, computers are kind of boring and stodgy. But from our perspective, there is an infinite number of cool and interesting things that could go on. But then when you up-level that to a plot point, someone could just say, okay, a program fights a computer, and that's not interesting anymore.
Yeah. Well, like I said, part of the reason for the books is educational as well as entertainment. So the first book, educating about a real threat that I believe in, and the second part is educating people about cybersecurity. The second book, Trojan Horse, is educating people about the state-sponsored cyber espionage, which is something that's going on all over the place. Like, how do governments carry this out? How do they use cyber espionage to further their national interests? And how do they work against each other? I wanted to educate that by making a story that is based loosely on things that we actually see going on these days. And at the same time, make it entertaining. And so the books, if you look at the structure that I've kind of set upon, it's the first quarter to a third is kind of how the story starts to build as the computer cyber stuff happens, like what's the infection and who's being hacked and how they're being hacked. And this is where you see Jeff analyzing stuff. And then it starts to roll faster and faster into more action as, Jeff's life's in danger or Jeff's trying to stop something really horrible from happening. And then it ends up boiling down into the end. It's like pure thriller.
Right. I thought it was interesting also that there was a personal aspect to it in that you didn't make the cyber criminal this kind of nameless, faceless, evil person.
Yeah.
And I know sometimes, when I get a virus, I'm just like, oh man, those guys. But it's very abstract. But there was an actual human in a room with a wife and a life and an apartment. And, he moves from one apartment to another. And that's like very kind of banal details. But it reminds you that when you get attacked or you get that mean toolbar that you're wondering, is that malware or not? There was a human being that pays rent and goes to the store who did that.
Yeah. And
is that a conscious choice?
It was a conscious choice to actually, and this is another example of not wanting to hand wave or go from point A to point B without a sound explanation for how the plot moved forward. I didn't want to have faceless criminals behind the whole thing that just get unveiled at the very end as diabolical people that have, magical powers to wreak cyber terror, but actually show really what's going on. It's part of the education and part of, I think, trying to make a thriller that people see anchored in reality, kind of. So it was a very conscious choice. And actually to put a human face on some of the characters, the person you're talking about in the book, he really isn't evil. He doesn't even really know that he's part of this plot. And So that kind of comes out too, that not everybody involved in something like this necessarily realizes the implications of what they're doing.
Right. And just as they are themselves building a distributed system for attack, they are part of a larger human distributed system where he was taking pieces of things and assembling something, but he was also the piece of a larger thing that was being assembled by someone else.
Somebody else, yeah.
Which makes one wonder in the context of terrorism or kind of nefarious plans, is it simply the will to do it that is preventing us from being attacked again, whether it be attacked in something as base as an airplane into a tower or something as subtle, comparatively subtle as a cyber attack. It's just simply, no one has just sat down and said, we're going to do this thing.
Yeah, I think it's lack of vision, really is what's the only reason that we haven't had it happen so far. Because if you kind of take a step back and say, how much would it cost to do something like this? Even something that is mildly, has a mild chance of causing destruction. It's actually a pretty low bar in terms of budget. If you look at the budget that Al-Qaeda had prior to 9/11, they were making several $1 million a year. And the Al-Qaeda attack itself cost a few $100,000, they estimate. So the kinds of numbers that you're talking about for hiring some, competent hackers in Russia or China to help you out, where they don't even have to know what they're doing, it's a pretty low bar in terms of number of organizations that would be capable of outsourcing that kind of work to. Because one of the big pushbacks I got from people as I started to talk about the plot is, oh, no, terrorists, they're not sophisticated enough to do this. I'm like, you don't get it. They don't have to be. They just have to know that this is a weapon they can use, and then they pay people that are sophisticated enough. There's lots of people they can pay.
When you write a book about something like this, are you concerned ever that you're giving people an idea? Like whenever people have we just had this attack in Aurora, Colorado, and people are trying to analyze it. And the first complaint that comes up is like, oh, there you go. Now you're giving the bad guys ideas. Yeah.
I don't believe in that, giving the bad guys ideas. I mean, the bad guys are going to come up with their ideas on their own. I think that's foolish to think that if you don't talk about it, nobody's going to figure it out, because people will figure it out. And in fact, it's better to talk about it before they figure it out, so you can determine what's our reaction going to be. Are we going to do something proactively to try to prevent it, or are we just going to wait for it to happen and then react like, oh my God, I can't believe they figured it out? The really ironic thing, speaking of giving people ideas, kind of ironic and really kind of gives me some pride, is that one of the blurbs I got for the book, when you write a book, you're supposed to go out and get blurbs from other authors that people recognize that will say something nice about your book. And one of the blurbs that I got for 0 Day was from Nelson DeMille, who wrote the book that had the airplane flying into buildings that people pointed at when 9/11 happened, saying he's the one that gave them the idea. Well, then he gave me a blurb for my book, which is kind of 9/11 cyber version, which I think I don't want it to play out the same way, but it's kind of interesting that kind of coincidence.
How worried should one be? Like, you're as educated and as inside as one could possibly be on this. If you're worried, then I'll be worried. Yeah.
Well, how worried should you be?
How worried should I be?
I think you should be pretty worried. I think that the legislation that's trying to go through Congress, for example, to try to put incentives and regulation on private sector running our critical infrastructure, I strongly believe in. I strongly believe we need it. I believe that if we let private industry do what it wants to do, it's not incented really to invest money and expertise into this, which I believe we need. And there's plenty of examples we've seen up until now about the poor state of cybersecurity. I mean, every week there's something that happens that you just look at and go, really? Passwords that aren't encrypted and weak passwords and software that's not been patched in several years. I mean, all of this you've been in the headlines over the last few years. And to examples of some guy that took pictures of the display on control systems for water outside of a town, outside of Houston, a small town, where he just hacked in within a few minutes with very little expertise in the SCADA systems, but it was able to get in right into the control system of the water supply. To another one of my favorite examples of a company that does penetration testing that was hired by the city of Los Angeles to do pen testing on their water supply. Within 24 hours, they got into the water supply computers to the point where they could have altered the chemical mix to a significant part of the county.
Wow.
And so that's really the state that we're in.
Yeah.
I don't think we can underestimate how bad things really are out there. There's certain spots, right, where there's good cybersecurity, but
sure.
For the most part, I think we've got a lot of weakness.
There was a thing, I think it was in Oregon maybe a year ago, where they hacked into the Department of Motor Vehicle signs.
Oh, yeah.
And it said, I-5 South
Zombies
closed,
ahead.
zombies ahead.
Yeah, I've seen that, yeah. In fact, somebody's been doing it here in Seattle.
Really?
Yeah, it's the last few weeks.
And see, that's a combination of physical security and cybersecurity. I mean, they just literally bring their laptop and they bust it into it and they plug it into the sign. Hopefully that's the least of the attacks that we'll see.
Yeah. Actually, there was another one yesterday. Somebody at Black Hat doing a talk on how locks at this company that makes locks for major hotel chains, the electronic locks, that there's a plug where you can connect a wire to
the lock itself?
To the lock itself. And the protocol that this device, the lock device has, lets you read the RAM of the device. So there's a cryptographic key in there, but you can suck it out. And then given the key, you can then unlock the door. You use it as a master key to unlock the door. So that's that's an example of where they actually had some good security, but then one weakness and
one can't even consider why someone would want to attack something. I mean, a year ago, I'm diabetic. I have an insulin pump.
Yeah.
A Black Hat attacked an insulin pump, overflowed its buffers over a radio frequency and caused it to give a lethal dose of insulin. Like, wow, really? I mean, is that what we're going to do? But of course, the point of that was to prove that it could be done and then spur everyone into action. Is that what needs to happen? A giant attack, and then we get scared, and then we fix something?
I think that's just human nature, right? I mean, people talk about it all day long, and then there's this very much, I don't believe you unless you prove it to me. And even what's shocking in this case is the evidence has been all around us. It's been a low hum of evidence. And then people get kind of immune to hearing about it. Oh, well, there was another attack, but nothing really big happened. So no big deal. Let's move on. Oh, well, another attack, nothing really big happened. And it's just going to be a matter of time before something really big happens. And then people say, oh my God, we should have done something. How did we let this happen? But that's just, I think, human nature.
So what are the URLs that people can check out to learn about the Jeff Aiken series of books?
So just Russinovich.com is the site to go to. Got information about all my books, including the nonfiction books that I write as well, and links to where you can buy them and see reviews of them.
Very cool. And 0 Day is in stores now and on Amazon, and Trojan Horse comes out in September?
Yep, early beginning of September. I also have a Jeff Aiken short story that's only 99 cents, ebook.
Nice.
Kindle and
Kindle single.
Nook and all the ebook vendors, major ebook vendors. That's coming out in August, I think August 8th.
Very cool. You know what you should do? Here's an idea for your third book, is you should make sure that there's malware in the ebook that gives other people copies of the ebook.
Yeah, spread it like a virus.
It could be a thing. Thanks so much for talking to me. I appreciate it.
Thanks, Scott. Thanks for having me on.
This has been another episode of Hansel Minutes, and we'll see you again next week.